So in this question, we're going to look at one of the ways we can determine the rate law for a chemical reaction. So in this case, we have X gas plus Y gas yields Z gas, and we have 3 trials. And this is called basically the initial rate method. So first of all, let's write the general form of the rate law. So the general form is the rate equals K, concentration of the first reactant, X, to the M, times concentration of the second reactant, Y, to the N. And if we look at this equation, what we notice is there's lots of variables, right? We know X, Y, and rate, so we know the rate, concentration of X and concentration of Y, but we don't know K, M, or N. Well, we can't solve a variable or solve an equation with 3 variables very easily. So what we need to do is do this in a special way. And that special way is essentially looking at comparing 2 trials. So the first thing I want to do is try to find the value of M. So when I look at my trials, what I'm looking for is a case where the concentration of X changes, but the concentration of Y remains constant. So if we look at these trials here, in the case of 1 to 2, X doesn't change. In the case of 2 to 3, X changes. In the case of 1 to 3, X changes. So we could compare either 1 and 3 or 2 and 3. Well, how do we decide which trials to compare? Well, we want Y to be constant. So if we look at trials 1 and 3, X changes, but Y also changes. It goes from 0.5 to 1. If we look at 2 and 3, X changes, but Y doesn't. So X is 0.2 and 0.4, and Y is 1 and 1. So we want to compare trials 2 and trials 3 to find the value of M. So if we go to trial 2, and we just plug in, rate is known. It's given here. 0.017804 equals K, concentration of X is known, 0.200 to the M, and concentration of Y is known, 1.000 to the N. Next, we want to do the same thing for trial 3. And again, we pick trial 2 and trial 3 because X changed and Y didn't. So the rate for trial 3 is 0.071395 equals K, in this case X is 0.4 molar, and Y is again 1.00 to the N. So now we've plugged in all of our values for trials 2 and trial 3, which again we picked because X changed and Y didn't. Now we want to divide this out. We want to divide these two by each other. And when we do that, we can cancel out like terms. So it's the same reaction, so K is a constant. And in this case, 1.00 to the N is the same on both, so we can cross it out. So what we end up with is 0.017804 over 0.071395 equals 0.200 to the M over 0.400 to the M. Now, these are just numbers, so we can simply divide them. And when we do that, we get 0.2494 equals. In this case, we could take the 0.2 and divide by the 0.4 and raise it all to the M. Well, 0.2 divided by 0.4 is a half. So 0.5000 all to the M power. So I just divided these two numbers and raised the whole thing to the M. And that's a mathematically valid thing to do. Now, how do we solve for this? Well, to solve for this, we have to take the log of both sides. So if we take the log of 0.24 0.94. When we take the log of this, the m comes out. So it equals m times the log of 0.500. Since log is an exponent, raising a power to a power is multiplying, so we can bring the m to the outside. So the m was here, and we bring it out here when we take the log. So m equals the log of 0.2494 divided by the log of 0.500. So I just divided both sides by log of a half. Now you just plug this into your calculator and you find that m equals 2.003, which is approximately 2. So we've now found the value of m. Now we need to find the value of n. And to do that, we want to do the exact same thing. We want to look for a trial where y changes and x is constant. And if we look at trial 1 and 2, we see that x is constant and y value changes. So these are the two trials that we want to compare. So for trial 1, we plug in to the original equation, rate we know, 0.008814 equals k, just make that a colon, equals k, concentration of x, which is 0.200 to the m, concentration of y, which is 0.50, 0.500 to the n. Same thing for trial 2, plug in the values we know. In trial 2, we know the rate, 0.017804 equals k, plug in the x value, 0.200 to the m, and plug in the y value, 1.000 to the n. Now we're going to do exactly the same thing. Divide the two trials and cancel out the like terms. K cancels, and in this case, the x concentrations and the m value cancel. So what do we end up with? Well, we end up with 0.008814 over 0.017804 equals 0.500 over, raised to the n, over 1.000 raised to the n. Now, these are just two numbers, so we can simply divide them. And here we can divide the numbers and then raise it all to the n power. So half divided by 1 is just half, of course, raised to the n power. In this case, when we divide these two numbers, we get 0.4951. Take the log of both sides. So the log of 0.4951 equals, when you take the log, you bring the n out, n times the log of 0.500. So when you take the log again, you multiply by the n, because this is going to give you the exponent. When you raise an exponent to an exponent, you multiply. So the n comes out to the outside. It was here, we move it out here. N equals, I'm going to divide both sides by log of half, log of 0.4951, whoops, I'm going to try that again. N equals the log of 0.4951 divided by the log of 0.500. When you do this math, you can tell that this number is about a half. And this number is a half, so it's going to be 1, because we have the log of a half over the log of a half, which is the same thing over itself. But n equals 1.014, which is approximately 1. So now we know the value of m and n. So now we can rewrite this rate constant. The rate expression equals k, concentration of x to the 2 squared, concentration of y to the 1, or we just leave it alone. So this is now the rate expression, which we have figured out here. Now let's look at the next question. what is the overall order of this reaction? Well, again, the reaction is rate equals K, concentration of X, squared, concentration of Y. So the overall order of the reaction is second with respect to X and first with respect to Y. So it's 2 plus 1, which equals third order overall. Finally, it says, what is the value of the rate constant? Well, to find the rate constant value and with the rate constant expression, pick a trial. It makes no difference which trial you pick. Pick any of the trials, but be consistent. I'm going to pick trial 1 and just plug in the values. The rate, in this case, 0.08, sorry, one more 0.008814 is equal to K, the concentration of X, which is 0.200 squared, times the concentration of Y, which is 0.500 to the 1. Next, square this and multiply it by a half. And what you get is 0.0200K is equal to 0.008814. Divide by both sides by the 0.02, and what you end up with is K equals 0.441. So this is how we can find the rate constant of this particular reaction. So in this case, we have determined the rate constant, the rate expression, we've determined the overall order, and we've determined the rate constant. This is a lot of work, but this is very important because this is using the initial rates, or one method in which we can find the experimental reaction orders of the individual reactants.